Well, hey there, kiddos. It's Petey the Polygon Plantain here to talk to you about some rectangles. Yahoo!
The first thing we're going to talk about is a rectangle. That's a parallelogram with four right angles that has the following properties. So the first property of a rectangle would be that opposite sides are parallel and congruent. So in this figure right here, if opposite sides are parallel, that means segment AD or DA would be parallel to segment BC or CB. Segment AB or BA would be parallel to segment DC or CD. We also know that they are congruent, so opposite sides are congruent as well. Segment AD or DA would be congruent to segment BC or CB. Segment AB or BA would be congruent to segment DC or CD. So in a rectangle, opposite sides are both parallel and congruent. The next property of a rectangle would be that opposite angles are congruent. So angle A would be congruent to angle C. Angle B would be congruent to angle D. On top of that, not only are they congruent, but all angles are right. Therefore, we know that angle A, angle B, angle C, and angle D are all right angles. The next property of a rectangle would be that consecutive angles are supplementary. And that makes sense, right? If all angles are 90 degrees, then obviously consecutive angles, angles that share a side, would have to add together to equal 180 degrees. 90 plus 90 is 180. That means that the measure of angle A plus the measure of angle B is 180. The measure of angle B plus the measure of angle C is 180. The measure of angle C plus the measure of angle D is 180. And the measure of angle D plus the measure of angle A is 180 degrees. The last property of a rectangle would be that diagonals are congruent and bisect each other. So if I were to draw the diagonals of this rectangle, segment AC and segment BD, those are congruent to each other because this is a rectangle. Not only that, but the diagonals also bisect each other. So segment AE or EA would be congruent to segment EC or CE. Segment BE or EB would be congruent to segment DE or ED. All of those are true because this is a rectangle. Now let's get into some rectangle theorems. The first one says if a parallelogram is a rectangle, then its diagonals are congruent. And we kind of just talked about this, right? If we know quadrilateral ABCD is a parallelogram, and we know that parallelogram is a rectangle, then we know that the diagonals, segment AC or CA, has to be congruent to segment BD or DB. The next rectangle theorem says if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So this is just the converse of the one we just talked about. If we know that the diagonals of a parallelogram are congruent to each other, so if we know that quadrilateral ABCD is a parallelogram, and we know that segment AC or CA is congruent to segment BD or DB, then we know ABCD has to be a rectangle.
Well, what do you know? It's example time.
Now, example 1 says a rectangular park has two walking paths, segment PR and segment QS. If the measure of segment PS is 180 meters and the measure of segment PR is 200 meters, find the measure of segment QT. So first thing we want to do with our figure, anytime you're given a figure and your instructions have some measurements, you want to label your figure. So it says the measure of segment PS is 180 meters. So for the measure of segment PS over here, we're going to put 180 meters. It also says the measure of segment PR is 200 meters. So we look at this diagonal and we're going to put 200 meters on that segment. Perfect. Now that we've labeled it, what are we trying to find? We're trying to find the measure of segment QT. So the measure of segment QT would be this segment right here. Interesting. We're not even given that diagonal. Well, we are told that PQRS is a rectangular park, meaning that it's a rectangle. And we just learned that in a rectangle, the diagonals are congruent to each other. So if we know the measure of segment PR, then we should know the measure of segment QS. So how do we find the measure of segment QS? It's equal to the measure of segment PR because the diagonals in a rectangle are congruent to each other. So the measure of segment QS is equal to the measure of segment PR, which we know is 200 meters. Now that we know the measure of segment QS is 200 meters, we can then find the measure of segment QT. How do we know that? Well, we know in a rectangle, the diagonals are congruent, just like we said, and they bisect each other. So they cut each other in half, meaning that if we know the whole measure of segment QS is 200 meters, we just multiply that by a half and we'll get the measure of segment QT. So half of 200 meters we know is 100 meters. That would be the measure of segment QT here. Now example 2 says quadrilateral JKLM is a rectangle if the measure of angle KJL is 2x plus 4 and the measure of angle KLJ is 7x minus 12, find the measure of angle KJL. So the first thing we're going to do, anytime you're given a figure and your instructions have some measurements, you're going to label your figure. So the measure of angle KJL is 2x plus 4. So KJL would be this angle right here. So we're going to label that with 2x plus 4. The measure of angle KLJ would be this angle right here. That's going to be 7x minus 12. Now we need to figure out how are we going to set up an equation here. Well, JKLM is a rectangle, which means it's also a parallelogram. So I know that opposite sides have to be parallel to each other. Now, how does this help us? Well, I know if opposite sides are parallel, let's look at these two sides right here, segment JM or MJ and segment KL or LK. If these two segments are parallel to each other, and let's say this diagonal, segment JL or LJ, is our transversal, then wouldn't alternate interior angles be congruent? So yeah, this angle right here would be congruent to this angle right here. Angle LJM would be congruent to angle KLJ. So if this right here is 7x minus 12, then this over here also has to be 7x minus 12. Similarly, if segment JK or KJ is parallel to segment ML or LM, then we know that these two angles right here, if we're looking at segment LJ or JL again as our transversal, these two angles right here, angle KJL and angle MLJ, also have to be congruent to each other. So if this one up here is 2x plus 4, then this one down here also has to be 2x plus 4. So, based on this information, I need to set up an equation to find x. How do I do that? Well, I'm trying to find the measure of angle KJL, this angle right here. So I need this angle to be included in my equation that I set up. So I'm going to say that since this is a rectangle, it has 4 right angles. Meaning that this angle right here, angle KJM, is a right angle. Meaning that if I were to add these two angles together, angle KJL and angle LJM, they would have to equal 90 degrees. So now all I have to do is substitute in what those angles are equal to. The measure of angle KJL we know is 2x plus 4. That goes in here. The measure of angle LJM is 7x minus 12. That goes in here. Now I can solve for x. So let's combine like terms. 2x plus 7x is going to give me 9x. 4 minus 12 is going to give me negative 8. I then add 8 to both sides, divide both sides by 9, and I get x is equal to 98 over 9. Now, why didn't I just divide this and then round it? Because if I round too early, I'm going to get the wrong answer. So keep your variables as exact as possible until you answer the question. What is the question? It wants us to find the measure of angle KJL. And again, the measure of angle KJL is 2x plus 4. So I take 98 over 9, plug it in for x here, and I simplify. 2 times 98 over 9. 2 is the same as 2 over 1, so I multiply 2 times the 98, 1 times the 9. I then add 4, and I get 25 and 7/9 or 25.7 repeating. Either way, those are both exact answers because I have this little bar on top. And don't forget, because you're finding the measure of an angle, you need to have degrees.
Don't slip up! Time for you try!
Okay, again, I'm dealing with a rectangle. This time it's rectangle ABCD. I'm given certain angle measures that I want to label right now. So the measure angle DAC would be this angle right here. That's 3x minus 6. The measure angle DCA would be this angle right here. That's x plus 11. Next, we are trying to find the measure angle BCA would actually be this angle right here. So just like last time, we know that this is a rectangle, meaning it's also a parallelogram. So opposite sides must be parallel to each other. Now, because of this, we can look at alternate interior angles. If I look at this segment right here and this segment right here as my two parallel lines cut by my transversal segment AC or CA, then these two angles right here, angle DAC and angle BCA, must be congruent to each other because they are alternate interior angles, meaning that they would be congruent by the alternate interior angles theorem. So I could say, since the measure of angle DCA is 3x minus 6, the measure of angle BCA must also be 3x minus 6. Similarly, we have two parallel lines cut by our transversal, which in this case is segment AC. We know that these two angles, angle BAC and angle DCA, BCA also form alternate interior angles. So they would also be congruent by the alternate interior angles theorem. And because they're congruent, their measures are equal. So if this angle right here is x plus 11, this angle up here also has to be x plus 11. Now, based on what we've marked up, we can now set up an equation to find x. How do we do that? Well, again, this is a rectangle. I am trying to find the measure of angle BCA, which is this angle right here. So my equation that I set up has to have this angle in. So what equation can I set up with this angle right here? Well, I know because it's a rectangle, the measure of angle BCD, this whole angle has to be 90 degrees because all angles in a rectangle are right. Therefore, this is a right angle. Therefore, it's 90 degrees. So I can say that the measure of angle BCA plus the measure of angle DCA has to equal 90 degrees. I then just plug in what those things are equal to. The measure of angle DCA is x plus 11. That's going to go in here. Measure of angle BCA is 3x minus 6. That's going to go in here. I can then solve for x by combining like terms. X plus 3x gives me 4x. 11 minus 6 gives me 5. I then solve for x by subtracting 5 on both sides, dividing both sides by 4, and I get x is equal to 21.25. Now, I'm not done. The question didn't ask you to find x. It wants you to find the measure of angle BCA. So what's the measure of angle BCA? Well, we know the measure of angle BCA is 3x minus 6 now. So we take 21.25, plug it in for x, and we simplify. 3 times 21.25 minus 6 is going to give you 57.75. Again, it's the measure of an angle, so make sure you put degrees. Now let's talk about how you determine if a quadrilateral is a rectangle. So you're going to be given a set of vertices that you're going to graph on the coordinate plane. And then you're going to connect them, and it's going to be a quadrilateral. You then have to determine if that quadrilateral is a rectangle. So there's two separate ways to do this. One would be with the distance formula. One would be with the slope formula. The questions usually specify which one you need to use. So using the distance formula, the very first thing you're going to do is verify that the quadrilateral is a parallelogram. Because in order to be a rectangle, the quadrilateral must first be a parallelogram. So to be a parallelogram, both pairs of opposite sides have to be congruent. So the first thing you're going to do is find the length of each side using the distance formula. If both pairs of opposite sides are congruent, then it's a parallelogram, and you can move on to step 2. If both pairs of opposite sides are not congruent, then you can just automatically say it's not a rectangle and move on to the next question. But if you know it's a parallelogram, you move on to step 2, and you find the length of each diagonal. If the diagonals of a parallelogram are congruent, then it must be a rectangle. So if you figured out it's a parallelogram, and then you figured out that that parallelogram has congruent diagonals, then you know it must be a rectangle. The other way to do it would be to use the slope formula. So you would find the slope of each side. If both pairs of opposite sides are parallel, then you know it must be a parallelogram, and you can move on to step 2. If both pairs of opposite sides are not parallel, then you automatically can say it's not a rectangle and be done. But if you know that both pairs of opposite sides are parallel and you know it's a parallelogram, you move on to step 2, which wants us to examine the slopes of the adjacent sides. The reason for this is because if the adjacent sides have perpendicular slopes, then it's a rectangle. And the reason for that is because if you know that it's a parallelogram, both pairs of opposite sides are parallel, and you know that the adjacent sides are perpendicular, that means that it's a parallelogram with all right angles. Therefore, it must be a rectangle. So let's try this. Example 3 says graph quadrilateral PQRS with vertices PQRS. Then determine whether the quadrilateral is a rectangle. Justify your answer using the distance formula. Okay, first thing we're going to do is graph this quadrilateral PQRS. So point P is at negative 6, 3. We go over negative 6 on the x-axis, up 3 on the y-axis, put point P. Point Q is at 0, 1. We go over 0 on the x-axis, up 1 on the y-axis, put point Q. Point R is at negative 1, negative 3. We go over negative 1 on the x-axis, down negative 3 on the y-axis, put point R. And then point S is at negative 7, negative 1. We go over negative 7 on the x-axis, down negative 1 on the y-axis, put point S. There is our quadrilateral PQRS. Next, we are going to determine whether this quadrilateral is a rectangle, and we're going to justify our answer using the distance formula. Remember, to determine if this quadrilateral is a rectangle, there were 2 steps. The first step is to determine if both pairs of opposite sides are congruent. If that's true, then it's a parallelogram, and we can move on to the next step. If it's not true, then we can stop, and we're done. So let's determine if this pair of opposite sides are congruent, segment PQ and segment RS. To do that, we need their measures. So let's first find the measure of segment PQ. The The measure of segment PQ, we use the distance formula, so we pick one of these points to be x sub 1, y sub 1, and the other one to be x sub 2, y sub 2. We plug in the coordinates to their corresponding spot in the distance formula, and we simplify. 0 minus negative 6 is the same thing as 0 plus positive 6, so that's 6, and then 1 minus 3 is negative 2. We then square these. 6 squared is 36, negative 2 squared is 4. Add those together, 36 plus 4 gives you 40. Now rad 40 can be simplified. To simplify a radical, we break it up into two numbers that multiply together to make 40, one of which has to be a perfect square. So that would be 4 and 10. So we break that up into rad 4 times rad 10. We chose 4 because it's a perfect square. The square root of 4 we know is 2, so it comes out of the radical. Square root of 10 we can break up into rad 5 times rad 2, but neither of those are perfect squares, so we can just leave this rad 10. So the distance or measure of segment PQ is 2 rad 10 units. Let's see if we get the same thing for the measure of segment RS. So we choose one of these points to be our x sub 1, y sub 1, the other one to be our x sub 2, y sub 2. Doesn't matter, you could have switched them. We plug in the coordinates to their corresponding spot in the distance formula, and we simplify. Negative 1 minus negative 7 is the same thing as negative 1 plus positive 7, so that's going to be 6. And then negative 3 minus negative 1 is the same thing as negative 3 plus positive 1, so that's negative 2. 6 squared gives you 36, negative 2 squared gives you 4. 36 plus 4 gives you 40, and again we have rad 40, so we could stop right here, and we know that those two are congruent to each other, or we can simplify this again just like we did over here. Remember, rad 40 breaks up into rad 4 times rad 10. We chose 4 because it's a perfect square, and the square root of 4 we know is 2. Rad 10 stays rad 10, so the measure of segment RS is also 2 rad 10 units, so we know those two segments have to be congruent to each other. Let's check this pair of opposite sides now. So in order for this to be a parallelogram, we need both pair of opposite sides to be congruent. So the measure of segment PS has to be equal to the measure of segment QR. So how do we find the measure of segment PS? We use the distance formula. We choose one of our points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Doesn't matter, you could have switched them. We plug in the coordinates to their corresponding spot in the distance formula, and you simplify. Negative 7 minus negative 6 is the same thing as negative 7 plus positive 6, so that's going to be negative 1. Negative 1 minus 3 over here is going to make it more negative, so it's going to be negative 4. You then square both of these. Negative 1 squared gives you 1, negative 4 squared gives you 16. 1 plus 16 is 17, and the square root of 17 is a prime number, so you can't simplify that any further. Let's see if we get the same thing for the measure of segment QR. We again use the distance formula, choose one of our points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in the coordinates to their corresponding spot in the distance formula over here, and we simplify. Negative 1 minus 0 is just negative 1. Negative 3 minus 1 makes it more negative. It's going to be negative 4. Negative 1 squared is 1. Negative 4 squared is 16. 1 plus 16 is 17. We again get rad 17. Therefore, both of these measures are rad 17 units, so those segments must be congruent to each other. Because we know both pairs of opposite sides are congruent, we know that this quadrilateral right here must be a parallelogram. But that's not what we're trying to figure out. We're trying to figure out, is it a rectangle? So how do we figure out if it's a rectangle using the distance formula? You first figure out if it's a parallelogram. If it is, then we have to find the measure of each diagonal. If those are congruent, then it must be a rectangle, because a parallelogram with congruent diagonals must be a rectangle. So let's find the measure of each diagonal. So we need to find the measure of segment PR and the measure of segment QS. To find the measure of segment PR, we use the distance formula. We choose one of our points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in the coordinates over here to the distance formula, and we simplify. Negative 1 minus negative 6, same thing as negative 1 plus positive 6, that's going to be 5. Negative 3 minus 3 is going to make it more negative, that's negative 6. 5 squared is 25, negative 6 squared is 36. 25 plus 36 gives you 61. 61 is a prime number, therefore our square root cannot be broken up any further. Now let's check. Do we get the same measure for the measure of segment QS? So we choose one of those points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in the coordinates to their corresponding spot in the distance formula over here, and we simplify. Negative 7 minus 0 is negative 7. Negative 1 minus 1 makes it more negative. It's going to be negative 2. Negative 7 squared is 49. Negative 2 squared is 4. 49 plus 4 is 53. 53 is a prime number, therefore our square root cannot be broken up any further. These two diagonals are not congruent because their measures are not equal. Therefore, we can say that PQRS is a parallelogram. It is not a rectangle.
Yellow! It's a you try!
Okay, doing the same thing here, except this time we are using the slope formula. So our first task is to graph Quadrilateral, LMNO. So our vertices are here. Point L is at negative 2, 2. We go over negative 2 on the x-axis, up 2 on the y-axis, put a point. Point M is at 0, negative 2. We go over 0 on the x-axis, down negative 2 on the y-axis, put point M. Point N is at 6, 1. We go over 6 on the x-axis, up 1 on the y-axis, put point N. And then point O is at 4, 5. We go over 4 on the x-axis, up 5 on the y-axis, put point O. There's our quadrilateral. Now, we need to determine if this is a rectangle using the slope formula. So this one's actually way easier. You just find the slope of each side. If opposite sides have the same slope, that means opposite sides are parallel, meaning it's a parallelogram. And if adjacent sides have perpendicular slopes, then they form 90-degree angles, meaning it's a parallelogram with all right angles, meaning it's a rectangle. So let's just find the slope of each side. We'll start with segment LO and segment MN. So segment LO right here, we're going to find the slope of this side using the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Pick one of these points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in the coordinates to their corresponding spot in the slope formula, and you simplify. 5 minus 2 is going to give you 3. 4 minus negative 2 is the same thing as 4 plus 2, which is 6. 3 over 6 simplifies to 1/2. So that's going to be the slope of segment LO. Let's make sure we get the same thing for the opposite side, segment MN. To find the slope here, we choose one of these points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in the coordinates to their corresponding spot in the slope formula, and you simplify. 1 minus negative 2 is the same thing as 1 plus 2, and then 6 minus 0 is 6. 1 plus 2 is 3. 3 over 6 is 1/2. So we know that both of these opposite sides must be parallel to each other because they have the same slope. Let's also check the other pair of opposite sides, segment LM and segment ON. So let's find the slope of segment LM first. We choose one of the points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in the coordinates to the corresponding spot in the slope formula and simplify. Negative 2 minus 2 is going to give you negative 4. 0 minus negative 2 is the same thing as 0 plus 2, which is 2. Negative 4 over 2 then simplifies to negative 2. Now we need the same slope over here to make this a parallelogram. So let's find the slope of segment ON. We pick one of the points to be x sub 1, y sub 1, the other one to be x sub 2, y sub 2. Plug in the coordinates to their corresponding spots over here, and we simplify. 1 minus 5 is going to give you negative 4. 6 minus 4 is going to give you 2. Negative 4 over 2 simplifies to negative 2. So both of these opposite sides also have the same slope, meaning that they are also parallel. So because both pairs of opposite sides are parallel, we know that LMNO must be a parallelogram. But that's not what we're trying to figure out. We're trying to figure out, is it a rectangle? Well, to determine if a parallelogram is a rectangle, you need to determine if all the angles are right. So are these adjacent sides perpendicular to each other? Do they have perpendicular slopes? Well, the slopes of segment LO and segment MN were both 1/2. Is 1/2 the opposite reciprocal of negative 2? Yes, it is. Therefore, the adjacent sides are perpendicular to each other, meaning that all the angles are right, meaning that this parallelogram is a rectangle. Now, example 4 says, prove if a parallelogram is a rectangle, then its diagonals are congruent. So in order to prove this, we're going to use this figure right here. So the if part, if you recall, is what you're given. So we are given a parallelogram is a rectangle. So here we are given EFGH is a rectangle, and we are trying to prove the diagonals are congruent. So segment EG is congruent to segment FH. Notice how I changed from my statement of what I'm trying to prove to a given and what I'm trying to prove. This is going to help us in our 2-column proof. So step 1 in a geometric proof is to mark up the figure with the given information. What are we given? We're given that this is a rectangle. Now that doesn't say anything is congruent to anything else, so we can't mark anything up yet. What we're going to do is use that information later on when we're game planning. Step 2 in a geometric proof is to state the given. So we're going to state the given. EFGH is a rectangle. The reason for that, it's given. Step 3 in a geometric proof is to come up with the game plan. How are we going to get from what we're given to what we're trying to prove? Well, if we know this is a rectangle, we know a couple different things. We know because it's a rectangle, it's a parallelogram. And a parallelogram has both pair of opposite sides congruent. So segment EH must be congruent to segment FG. Segment EF must be congruent to segment HG. We also know that because it's a rectangle, all angles must be right angles. So with that, how are we going to prove that the two diagonals are congruent? Well, I quickly want you to look at triangle EHG right here, and then triangle FGH over here. You can see that the two triangles overlap right here. If we look at these two triangles, they have one pair of corresponding sides that we know are congruent. Segment EH is congruent to segment FG. they also share segment HG right here. So we know segment HG is congruent to itself by the reflexive property. We also know that both triangles have a right angle right here. So we could say that angle H down here has to be congruent to angle G over here, or angle EHG has to be congruent to angle FGH, because all right angles are congruent. Now, we know that two pair of corresponding sides are congruent, and the included angle is also congruent within those two triangles. Therefore, the two triangles would be congruent by side, angle, side. Side, angle, side congruence postulate. And if we know those two triangles are congruent, we can then say segment EG has to be congruent to segment FH, because CPCTC, corresponding parts of congruent triangles, must be congruent. And these would be the corresponding parts of those two triangles. So let me show you how this works. First, we want to show that both pair of opposite sides are congruent. But in order to do that, we have to say that EFGH is a parallelogram. And the reason for that, that's just the definition of a rectangle. A rectangle is a parallelogram. Now, why do we have to say that it's a parallelogram? Because we want to use some of those parallelogram theorems. The first one being that both pair of opposite sides have to be congruent. This time, we only need segment EH and segment FG, so we can just say that segment EH is congruent to segment FG because opposite sides of a parallelogram are congruent. Next, again, because we're trying to show that these two triangles right here are congruent by side, angle, side, we've already shown that one side is congruent to one side. We need to show the other side is congruent. So we say that segment HG is congruent to segment HG because of the reflexive property. Anytime something is congruent to itself, that's the reflexive property. So we have two pairs of corresponding angles in one triangle congruent to two pairs of corresponding angles in the other triangle. We now need the included angle, the angle between those two congruent sides. So how do I show that these two angles are congruent? Well, they're both right. So I first say that these two angles are right angles. Angle EHG and angle FGH are right angles because that's just the definition of a rectangle. A rectangle has four right angles. Next, because these two are right angles, I can say that they must be congruent to each other because, if you recall, all right angles are congruent. Now I've shown that two pairs of corresponding sides in one triangle are congruent to two pairs of corresponding sides in the other triangle, and the included angle in one triangle is congruent to the included angle in the other triangle. Therefore, these two triangles right here, triangle EHG and triangle FGH, would be congruent by side, angle, side congruence postulate. Now we're not done. We're trying to show that the diagonals, segment EG and segment FH, are congruent. Well, since I've shown that these two triangles are congruent, I could say that their corresponding sides, segment EG and segment FH, must be congruent because corresponding parts of congruent triangles are congruent, CPCTC.
Gonna peel back the layers for you try.
This time, we are again given that the quadrilateral ABCD is a rectangle, and we are trying to show that triangle BAD, this triangle up here, is congruent to triangle CDA, this triangle down here. So step one in a geometric proof is to mark up the figure with the given information. We're given that ABCD is a rectangle. It doesn't say anything is congruent to anything else, so we can't mark up that yet. We'll get to that when we get into our game plan. Step two in a geometric proof is to state our given. We're given that ABCD is a rectangle. The reason for that, it's given. Step three in a geometric proof, come up with the game plan. How are we going to get from what we're given to what we're trying to prove? So again, we're given that this is a rectangle, and we're trying to show that this triangle up here is congruent to this triangle down here. Well, again, because this is a rectangle, we know it must be a parallelogram as well. And because it's a parallelogram, we know both pairs of opposite sides are congruent. We also know that all angles are right because it's a rectangle. One other theorem that I can use is that if this parallelogram is a rectangle, which it is, then the diagonals must be congruent. Segment AC must be congruent to segment BD. So I'm not going to mark that up because it would be a little too confusing right here, but just know that these two diagonals are congruent to each other. Well, with that information, I can prove this triangle, triangle BAD, congruent to this triangle, triangle CDA right here. I can prove them congruent two separate ways. One would be the side angle side congruence postulate, and one would be the side 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 congruence postulate. So I'm actually going to do it with the side 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 congruence postulate. So how does that work? Well, I know that because this is a rectangle, I want to show that these two opposite sides are congruent to each other. So how do I do that? Well, I first need to show that ABCD is a parallelogram. And the reason for that is just definition of a rectangle. A rectangle is a parallelogram. Now, why did I have to show that ABCD is a parallelogram? Because I wanted to use one of the parallelogram theorems, which says opposite sides of a parallelogram are congruent. So segment AB is congruent to segment DC because opposite sides of a parallelogram are congruent. So I have one pair of corresponding sides congruent in these two triangles. I need the other corresponding side congruent. Well, they both share segment AD over here. So I'm going to say segment AD is congruent to segment AD by the reflexive property. We then say the last pair of corresponding sides, the diagonals, must be congruent to each other because if a parallelogram is a rectangle, then the diagonals must be congruent. That was one of the theorems we talked about today. So now I have shown that all three pairs of corresponding sides are congruent within these two triangles right here. So I could say that these two triangles then must be congruent by the side-side-side congruence postulate. And I'm done.